hexagonal close-packed structure. In this module, you will learn how the constituent particles of solids are packed to form a hexagonal close-packed structure. Close packing in one dimension. Let us begin our study by considering the constituent particles of solids as hard spheres. In the close packing in one dimension, the particles are arranged in a row touching one another. In this arrangement, each particle is in contact with two adjacent particles. Hexagonal close packing in two dimensions. In the hexagonal close packing in two dimensions, one row of close-packed particles is placed above the other in such a way that the particles of the second row fit into the depressions of the first row. Similarly, a third row is placed above the second one such that its particles fit into the depressions of the second row, and so on. This forms a close-packed layer of particles in which the particles of the first row are aligned with that of the third row, and the particles of the second row are aligned with that of the fourth row. In such a layer, each particle has 6 immediate neighbors. If the centers of the 6 immediate neighbors of a particle are joined, a regular hexagon is formed. Therefore, this kind of packing in two dimensions is called hexagonal close packing. In the hexagonal close packing, very less empty space is left. The empty spaces left are triangular and are called voids. Hexagonal close packing in three dimensions. In the hexagonal close packing in three dimensions, one hexagonal close-packed layer is placed over the other in a manner that the particles of the second layer cover the depressions present in the first layer. As a result, the particles of the first and second layers are aligned differently. Now, at some places, the particles of the second layer cover the triangular voids of the first layer. At such places, a new type of void is formed. This void is surrounded by 4 particles and is called a tetrahedral void. Alternatively, at other places, the triangular voids of the first layer coincide with that of the second layer. At such places, a new type of void is formed. This void is surrounded by 6 particles and is called an octahedral void. The third layer is then placed over the second layer, covering its tetrahedral voids. The particles of the third layer in this case are exactly aligned with that of the first layer. So, if the first layer is A-type and the second layer is B-type, the third layer will again be A-type. This pattern repeats in the subsequent layers and is called AB-AB packing pattern in 3 dimensions. The structure resulting from this packing pattern is called a hexagonal close-packed structure. Coordination number in a hexagonal close-packed structure. In a hexagonal close-packed structure, each particle remains in contact with 12 particles. This number that determines the number of particles in close proximity is called coordination number. So, in a hexagonal close-packed structure, the coordination number is 12. In this module, you have learnt, in the close packing in one dimension, the particles are arranged in a row touching each other. In the two-dimensional hexagonal close packing, the particles of one row are placed in the depressions of the other row. When two-dimensional hexagonal close-packed layers are placed one above the other in AB-AB packing pattern, a hexagonal close-packed structure is formed. The number that determines the number of particles in close proximity is called coordination number. It is 12 in the case of a hexagonal close-packed structure.